All right. So we're going to talk a little bit about the Gravimetric Analysis Lab. And gravimetric analysis is basically just a fancy term for we are going to precipitate something. We're going to set up something so that we know what will precipitate, so we can identify an unknown using stoichiometry. So basically what we're doing here is we've got something M2CO3, okay? We know it's in group 1. We don't know what it is, okay? And that's actually better than people will know a lot of times when they're really doing this. They probably wouldn't know what group it's in necessarily until they do some experimentation and figure out how many of the what the ratio is there. But they're telling us this is M2CO3, so it's got to be something in group 1. Carbonate is a 2- ion. So anything in group 1, it's going to take 2 of those because they all have 1+ charges to balance out the charge on the carbonate. So we know that when we put this thing into water, it's going to dissolve because remember the alkali metals, they never precipitate with anything, okay? And so as soon as you put it into water, it's going to split apart into ions, okay? Now, the other thing that we know is that calcium carbonate is insoluble in water. It will actually precipitate, okay? So what we can do is we can put this into a solution of calcium chloride, or we can add the calcium chloride to the metal carbonate, and the calcium carbonate is going to precipitate, okay? And then, because we know that this is basically what's happening there, it's a double replacement reaction where the the calcium is going with the carbonate to make a solid, we can actually write a balanced chemical equation for this, and we can figure out the molar mass of this, okay? And once we figure out the molar mass of that, then we can compare it to the molar mass of the things in group 1 on the periodic table, and we can figure out exactly what this is, okay? So that's the basic idea there. Sorry about these. Get rid of this real quick. Okay. So here's the pre-lab questions. These are very similar to the post-lab questions, okay? So the first thing they're showing you here is basically this is the process you're going to use, okay? You're taking the mass of the crucible plus the metal carbonate. You're drying it out to make sure that you've gotten rid of all the water before you put it into solution, okay? Because you want this just to be the metal carbonate. You don't want it to be a metal carbonate with 5H2O or something like that, okay? That can mess up your experiment. So we want to make sure that it's not like that. So once you dry it out, then you've got a mass of 1.972, okay? Once you subtract those two numbers from one another. So that's the original mass of the unknown, okay? Then we take the mass of the filter paper, and then we're basically doing the chemical reaction where we dump the calcium chloride and the metal carbonate together, and then we figure out how much CaCO3 we get out, and it ends up being about 1.838 grams, okay? So then they want us to find the moles of CaCO3. I think you guys are fine on that. You just use the molar mass of the calcium carbonate there. Then we need to find the molar mass of the M2CO3, okay? Now, that's a little bit more tricky, but what we have to use here, oops, I picked up the pen. What we have to use here is our balanced chemical equation, okay? Because we know the mass now of the calcium carbonate, right? So we can use that mass, the calcium carbonate, to figure out how many moles of the M2CO3 we should have formed, okay? And we know the mass of the M2CO3, so if we can take the mass then divided by the moles, that's going to give us the molar mass. So let's see here. This is actually in a 1-to-1 ratio, so really you don't even have to do a lot of extra work here. Once you find the number of moles of the calcium carbonate, the CaCO3, that's going to be the same as the number of moles of the M2CO3, okay, because it's a 1-to-1 mole ratio according to this equation. So as soon as you find this right here, moles of calcium carbonate, you can take the mass of your M2CO3 right here, take that mass and then divide it by the number of moles of the N2CO3, which is the same as the moles of the calcium carbonate. That's going to give you your molar mass, okay? So once you have your molar mass written in here, it should be fairly easy to figure out the identity of the N2CO3, and that's actually what question 3 is leading you through. It says calculate the molar mass of the following group 1 metal carbonate. So these are the possibilities. It could be lithium carbonate, sodium carbonate, or potassium carbonate. And once you figure out the molar masses of all 3 of these things, you can compare it to the molar mass that you have up here, and then you should be able to figure out which one of the 3 it actually is. Okay? And it's, it's not going to be exact. It's going to be close. Okay? Then you're going to calculate the percent error in the molar mass determination. So this is your experimental molar mass, okay? These right here are the accepted values, okay? So remember, the percent composition, you're going to take the actual or experimental minus the, well, here, I should probably write this the correct way here. The experimental minus the accepted divided by the accepted times 100, okay? So you take the experimental value, which you found right here. You divide that by whichever one of these 3 that it is, lithium carbonate, sodium carbonate, or potassium carbonate, and just plug that into the equation, okay? The accepted value, experimental minus accepted over accepted times 100, and that should give you your percent error, okay? All right, so that's that. Get rid of all this, and then we'll look at the post-lab for a second. Hopefully that makes sense what we're doing. It's a fairly simple lab. Let's see here. Anything weird about that? We're doing the brushing technique again, so just make sure that you're paying attention to that. You're going to need to get started right away. Oh, okay. There is one thing here. Now, I may have to tell you this in class too, but they have you tear a little corner out of this filter paper, and what that does, it supposedly helps it to filter a little bit faster. And I'm not sure exactly what the physics of that is, but evidently that does help a little bit. So I think that's why they do it. So anyway, go ahead and do that with the corner of your filter paper. I know it's a little bit strange, but I don't know that there's anything else here that's out of the ordinary. Just make sure you're following the directions. We are going to put these in a drying oven overnight and then measure the mass the next day. We'll probably only get one trial of this in, but it looks like that's all they're having you do anyway. And then the post-lab calculations, calculate the moles of precipitated calcium carbonate. That's just like in the pre-lab. Okay? Calculate the molar mass of the unknown, again, just like the pre-lab. And from the calculated molar mass, identify the unknown, and then calculate the percent error, again, just like the pre-lab. So there's nothing different there. If you understand how to do the calculation on the pre-lab, you should be able to do it in the post-lab. And you're just going to pick the one that's closest to the number that you have, whichever metal carbonate is closest. And I think most people last year got pretty close to the right answer here. As long as you're careful, as long as you don't lose too much mass off your filter paper, as long as you don't sneeze on your filter paper or something like that, you should be fine. And then review the procedure and list possible sources of errors that would cause the molar mass of the unknown to be A, too high or too low. So you're just going to have to think through the experiment. And again, they ask this question all the time on AP tests. They want to know if you can analyze what would cause the molar mass to be too high or too low. So you just need to go back, think through the calculations that you made, okay, and see if you can figure out some things that would make the mass too high or too low. Okay. So for example here, the molar mass is the grams of M2CO3 divided by essentially the moles of CaCO3, since it's a 1-to-1 ratio there. So anything that you can think of that would make this number, the moles of CaCO3, higher than it should be, is actually going to make your molar mass, this number is higher, it's going to make your molar mass lower, because molar mass is grams divided by moles, right? Anything you can think of that would make this mass higher would make the molar mass higher, okay? So those are the sorts of things you need to be thinking about on that question, all right? Okay, hopefully that makes sense. Again, pretty simple lab. You guys should do fine with this one. So, all right.